Hi, my name is Uday Kumar Satisilan, metric number 211090989. So I'm from group 33. So here to discuss about the hazard identification, risk assessment and risk control at laboratory faculty of electronic engineering at UNIMAP FKTEN. So to begin with, I would like to talk about the crucial role of occupational safety and health, which is the OSHA, especially within educational institutions like university and colleges. In Malaysia, OSHA is a top priority, supported by legislation such as Occupational Safety and Health Act 1994, which ensures that all employees, students, and visitors are protected from workplace hazards. This is particularly important in an environment like laboratories and workshops in university, where the staffs and students may face various risks ranging from chemical to electrical hazard to physical and agronomic dangers. We are rely on systematic approach known as the hierarch, hazard identification, risk assessment, and risk control. HIRARC helps us identify hazards, assesses associated risks, implement effective controls to minimize and eliminate those risks. At University Malaysia Perlis, especially within the Faculty of Electronic Engineering Technology, applying a HIRAC is essential not just for legal compliance, but also for fostering a strong safety culture among students and staffs. The process aligns with international best practice and local policies, and it plays a key role in maintaining a safety environment. This presentation, we will highlight the importance of OSHA and HIRAC process in our laboratories and workshops, using a detailed case study to demonstrate how we can ensure safety measures in the faculty. Okay, now I will proceed with the case study. We are focusing on 5 hazards in total for this project. So to begin with, hazard 1, which is the name Basic Power Electronic Lab, FK10, and its function for practical environment for students and researchers to study, analyze, and with equipments of power electronics. And the person in charge is a lab assistant. Subjects using the lab is power electronics, electrical circuits, control system, and renewable energy. The capacity is up to 30 people. Next, next is the computer simulation lab in FK10 faculty. And this is a place where they used to learn electronic engineering simulations as well as computer engineering, and followed by the person of in charge as a lab assistant or technicians. And the subjects used here is AutoCAD, PCB design, computer aided design, and so on. And it's up to 30 students. And the hazard 3 is an IC design lab from FK10. It's a lab where they used to study about the IC designing as well as conduct a practical sessions and project relevant to the IC design. And the person in charge is a lab assistant or technicians, where they will conduct various test equipments and possibly using computers where simulation software that can accommodate around 30 students. Next is hazard students. Next is hazard 4, which is the microprocessor lab from FK10, and it's for microprocessing system and embedded programming using its computer. And so it can fit up to 25 students, and followed by the last one, which is the clean room microfabrication lab from FK10, where this is a facility in Unimap that they use for microprocession, microfabrication, as well as fault analysis training. And here it can accommodate with a very restricted amount of students, which is around 15. And also for the usage, they use for semiconductor designing, processing, and advanced materialization.
Greetings to everyone. My name is Nesh Analaki Magendran and I would like to present about types of hazard identification. So the first hazard is at Basic Power Electronics Lab at FK10 Unimap. The hazard identifications is faulty cables that are headed improperly due to aging and exposing. So the possible effects are exposure to live wires, faulty connections, improper installation or touching energized terminals. So underlying cause, lack of insulation on wires or terminals, and damaged cables reused in experiments. So the risk level for this hazard is medium type. So what are the control measures? So conduct regular equipment inspections for installation damage or loose terminals and encourage students to report issues. So moving to next hazard, hazard 2, computer simulation lab. So hazard identifications, poorly arranged or hanging network cables, power cords or USB peripherals across walkways or under desks. Exposed power cable on the floor. So what are the possible effects? Electric shock and fire hazard. So the underlying cause, lack of insulation on wires or terminals, cleaning staff or users may move cables carelessly, creating trip hazards. So this type of risk level is medium. And what are the control measures? Encourage students to report issues, use rubber floor cable covers to enclose and shield any cables running across working parts, and secure cables with clips, ties, or velcro straps to keep them off the floor or bundled safely.
A very good morning. I'm Anura Analaki Jongjut, and my matrix number is 221091035. So now I'm going to present about the hazard 3, which is in IC design lab. So based on our survey with the lab assistant, so she mentioned that this lab usually occur the chair easily break. So based on our observation, so this will be our hazard identification. So the chair is easily break, then it might cause the student to fall the chair, or when the student falling down from the chair, so this might disruption to the lab session. And lastly, it will cause back pain and head injury to the students. So for the risk assessment, so we assume that it's like likelihood, because it's very linearly the possible the chair to be loose or to fall down or to break. It depends on how the student use the chair. So next, the consequence is moderate. So because the fall can cause the back pain. And lastly is the risk level. So we assume it's just a medium risk, because it's like not every time will happen. So how we going to control this hazard? So we must establish the monthly maintenance to inspect the chair to all the lab, so it might reduce the cases. So next, replace the broken chair with the ergonomically safe chair, means like use the proper chair instead of the uh, material such as plastic. So lastly is encourage students to do report when there's any broken chair, so that they can have a regularly maintenance to the lab. So next hazard that we study is hazard 4, which is in microprocessor lab. So this lab have two hazard that we have identified. So first is the voltage regulator is exposed on the table. So based on the figure below, we can see that the regulator is exposed to the table. So it might cause the short circuit and overheating due to the contaction with the conductive surface. So as we know, all the lab using the wood table. So if it's overheated, so it might burn the lab. So next will be a cable stress due to tension caused by the poor arrangement. So we can see from the figure also. So there's a lot of cable tightening together, and tension can damage the insulation and sparks, and can cause the sparks. So we can see there's a huge cable that connected together without proper arrangement. So from this hazard, so this is our risk assessment. So there are two types, which I mentioned just now: voltage regulator, to expose, and cable stress. So likelihood the hazard occur is possible for both, Then the consequence, voltage regulator is moderate, cable stress is minor, and the risk level for both hazard is just medium risk. So how we going to control this risk? First is for voltage regulator exposed to the table. First is use the thermal spacers under the regulators so it won't contact directly to the surface. Then next is mount the component properly so it won't cause overheating and won't cause the short circuit happen. So lastly is the cable stress due to tension caused by poor arrangement. So how we going to control is by use a routing trace to place cable perfectly. So the cable will have a good arrangement. So it might won't be contact to each other and cause the cable stress. So lastly is allow slack in wiring to reduce the strain in the lab. So I think that's all from me. Present hazard 3 and hazard 4. Next, stage 1 will proceed to hazard 5. Thank you.
My name is Tejuan. Now I will present the hazard 5 for the green room microfabrication lab. The main hazards here include the high voltage equipment, extreme the machine temperature up to 1200 degrees Celsius, and hazardous chemicals like solvents and acids. Gas can cause electrical shock, severe burns, explosions, and respiratory irritation. The risk assessment rates high voltage as high risk, while extreme temperature and chemicals are extreme risk due to their severity and likelihood. To control their hazards, we need to insulate the equipment, clear the warning signs, and proper the PPE such as glove and lab coats, and also correct the storage with safety labeling. Their measure follow the hierarchy of controls to minimize the harm. Overall, managing their risk promote a strong safety culture, protect the environment, and supports a safe and sustainable lab. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Mukhlis bin Muhammayani and my student ID is 211092514. So now I will continue on the impact and consequences of our HIRAC project to society and environment, especially in the aspect of safety and health. First of all, from the societal perspective, this project has really helped improve the safety culture in our faculty, which is FKTEN at UNIMED. By identifying hazards and taking preventive steps, students, lecturers, and lab technicians are now more alert and responsible when using lab equipment. For example, in the IC design lab, even simple things like unstable chairs were considered a hazard. Meanwhile, in the clean room microfabrication lab, where high voltage and chemicals are involved, the awareness level is even more critical. This kind of awareness is very important because it helps prevent accident and injuries. When less accident happen, there's less disruption to our classes and projects. It also reduces the burden of healthcare and insurance, which is a positive impact not only for individuals but for the university as a whole. At the same time, this process shapes us, the engineering student, to become future professionals who are safety conscious and follow industry standards. Now, looking at the environmental side, the implementation of HIRAC helps make sure that our labs operate in a safe and eco-friendly way. Proper cable management and safe storage of chemicals reduce the risk of fire, electrical failure, and toxic spills, especially in the clean room where we handle solvents and acids. The use of fume hoods, clear labeling, and proper ventilation ensures that we avoid contamination and protect both human health and the environment. These practices are not only avoiding fines and meeting regulation, they help us build a long-term safety mindset, regular audits, training, and following OSHA 1994 and DOSH guidelines make safety parts of our daily routine, not just something we do during inspections. In the bigger picture, this project supports sustainable development and professional ethics in engineering. It creates a campus environment where safety is a shared responsibility, not just a rule to follow. Each shows how university like UNIMED can lead by example in promoting safe and sustainable engineering practice. So now I will continue on conclusion of our case study project. This project has shown how important it is to apply HIREC, which are hazard identification, risk assessment and risk control, in the labs of the Faculty of Electronic Engineering Technology UNIMED. We access 5 labs, which are Basic Power Electronic Lab, Computer Simulation Lab, IC Design Lab, Microprocessor Lab, and the Clean Room Microfabrication Lab. We found several hazards such as exposed voltage part, poor cable management, unstable furniture, high heat equipment, and chemical risk. To reduce these risks, we propose solutions like better cable trace, regular inspection, safety training, and proper PPE such as gloves and goggles. The project not only improve lab safety but also helps build a strong safety culture that follow OSHA 1994. It prepares us as future engineers to always prioritize safety, health, and sustainability in our work. In short, HIREC is not just a safety requirement, it's our responsibility for a better and safer future.